Assalamualaikum and hi to the doctor. So my name is Nukman Arif bin Nasaruddin and my student ID is 17129532. So I will present my answer for part 1 over 2 SIN 2002 session 2021-2022. So the question is, first create a CC+ program that utilize 3 user-defined prototype function according to the selected project. Validate the solution using manually or by any mathematical tools. The third one, present your answer in presentation slide. So we take note that the value of A, B, and C are the last 3 digits of my ID. So my final project topic is for part A, root finding, is a A2, Newton-Raphson method. For the part B, numerical integration, B2, composite Newton codes, and the part C, initial value problem, C3, the Hans method. Okay, so part A, the question is find a root of the following function in 6 decimal places. For this part, I have selected the A2 method, which is Newton-Raphson method. Here the equation for the fx is equal to 0.25 x power 4 minus 0.5 x power 3 minus 0.0002 x squared minus 1.03 x plus 1.abc. Okay, this is the theoretical information for the Newton-Raphson method. Is the one of the open method for the root finding based on geometry of triangle, require one starting point to start iteration, fast conversion. The formula is here, si plus 1 is equal to si minus function of si over derivative of si. The part B, the question is evaluate the following integral in a significant figure. So this part, I have select B2, Newton codes composite Newton codes. Here the formula. The lower limit is 0.abc to the upper limit is 1. In this B2, they have two fractions, the two parts. The first one for composite trapezoidal rule, and second one composite Simpson rule. For the first one, is a h over a times with fa. A is the lower limit, time and plus with 2 times with summation of this plus fb. B is the upper limit. H is step size, and n is an even or odd number for trapezoidal. Okay, next for the Simpson rule is the h over 3 times with fa. Same a is the lower limit, plus with 4 times with summation of this, plus 2 summation times with summation of this, plus fb. B is the upper limit. Same, h is the step size, b minus a over n. But in this case, n is only valid for the even number only. Odd number is not valid. Okay, next is for the part C. The last part, solve the following initial value problem in 6 decimal places. Here the dy dx. Initial x is 0, y is 2. And this part has select C3, the Hans method. Okay, is the general formula for the Hans method. First, we calculate the xi plus h. Xi plus 1 is the si plus h. H is step size. For that, we calculate the value of k1, value of k2, and last we calculate the value of yi plus 1, which is I is from 0, 1, and go so on. It's the general formula for the Hans method. Okay, so we take a look for my answer, project code answer, my C++. Okay, so in this part, I include the IO stream for input-output function, CMAT for the power, and the iomanic for the set position, setting figure, or decimal places. std library for the exit function. So I define the C here for the part C3, define B2S for the part B2 Simpson, define B2T for the part B2 trapezoidal, fx here for the part A2, and the gx here for the derivative for part A2. So I'm using namespace std, and I declare 3 user-defined function prototype. The first one, double Newton-Raphson for the part A2, double modified composite for the B2, and the last one, double Hans method for the C3. So it's our main body function, integer Z. So see out this. The first one for the Newton-Raphson method, second one for composite Newton codes, the third one Hans method. So I ask user to enter integer 1, 2, 3 to choose the method they want. So I use a switch case. So case 1 for the Newton-Raphson, A2. For the case 2 for the modified composite, B2. The case 3 for the Hans method, C3. Other than that, the default and will print out you enter wrong integer to showing the method. Please try later. Okay, if the user enter the number of 1, this will calling the function Newton-Raphson. So in this part needs a 6 decimal place. I declare of this double A, B, C, integer S is equal to 1. So I see out, welcome, you are choosing Newton-Raphson. We ask user to input value of A, B, C, the initial value of X. But then enter the integer between 1 to 12 for decimal places. Then we fix that according what user enter for D. Next, we print out the result Newton-Raphson method. And then we do a do while function to execute Newton-Raphson method. And the last one, the root for this equation is this function is first user function for the Newton-Raphson method. Here the example, I choose 1 Newton-Raphson, enter value of A 5, B is 3, C is 2. Initial value is 0. For decimal places, I put 6. So here the output, the root is 1.166151. Same, I use the Microsoft Excel to validate my answer with C++. I also use a2zmath.com website to validate to my answer. Here the comparison for part A2, C++, the root is here 1.166151. For the Microsoft Excel, the root is 1.166151. For the a2zmaths.com website, the root is 1.166151. Okay, next for the second user-defined prototype function, if the user enter integer 2, this function will call and execute. So this needs a significant figure. For the composite Newton code has two options, whether use trapezoidal or Simpson-Newton. So I ask user to enter 1 for trapezoidal and 2 for Simpson. And if the W is equals to 1, the part of composite trapezoidal method will execute. Here I declare double total. I enter value of A, B, C, the upper bound, number of segment. For this part, the number of segment can be even or odd. So we will execute the composite trapezoidal method and I see other approximation integration and the absolute relative error. So here the example, I choose composite trapezoidal number 1. Enter A is 5, B is 3, C is 2, upper bound is 1, number of segment 4. So number of standard figure I choose 8. Then he will output the value for the approximate integration. In this part, using 4 segment is 1.788068. I also use Microsoft Excel to compare my answer and also use a HeMelt help website to compare my final answer. and for B2 trapezoidal, C++ will print out approximate answer is 1.78800068. Same goes to the Microsoft Excel, we display the same output. And also to HeMelt website also print the same output for each significant figure. Next, if the user print out the value of 2, the part for the composite Simpson method will execute. So I declare integer I and D. Here, I enter value of A, B, C, enter the upper bound, enter the even number. Because in this part, only even number will work. So enter the integer for significant figure, and this part I use 8. Then we'll compute the composite Simpson method, I use for total and for the sum, and then lastly we print out the approximation integration and the absolute relative error. And if I also make else function, because if let's say user input 3 and above, we will see out you enter invalid integer. Thank you. So for the example composite Simpson, I enter A is 5, B is 3, C is 2, upper bound is 1, significant X, number of segment 4, because even number 4. So we print out like this. The approximation is 1.786668 in 8 significant. The absolute relative true error is same with Microsoft Excel. In this part, I use Microsoft Excel and eMathHub website to compare my answer with C++. So in this B2 Simpson, the approximate answer is 1.7866668 in 8 significant figure. Same goes to Microsoft Excel and same goes to eMathHub website. Okay, last one. Let's say the user enter the integer for 3 for method they want to show. The third user defined prototype function will call it. It's for the part for the Hans method, the third one. So in this function, double Hans method need 6 decimal places. I use array for this part. And next, input the value of A, B, C, initial condition of X node, Y node. For we ask for user for what value of X do you want to find the value of Y. So enter the step N, and for example I use 100 as N, and we'll print out this part. For we also ask user to fix the decimal places. In this part we use 6 decimal places, and if I use array, I use for function and include array of X and Y to find the solution using Hans method. And finally we'll see it out by using Hans method. Value of Y at X what is what, and then lastly the relative true error is what. For the part Hans method, here we include value of A is 3, B is A is 5, B is 3, C is 2, X naught is 0, Y naught is 2, the value of X is 2. Steps N, I use 100, so the step size is 0.02. So for the decimal places, I use 6. Here the solution is quite long. Here a few for my answer. Until here 100, we got X is 2, Y is 0.663238, and the relative error 0.019605. I compare with eMathHub website. Here the final answer sets 100 for Y. Also I use Microsoft Excel. It's quite long, but here the answer here 0.663238. So we compare using Hans method C++. The value of Y is 0.663238. The relative true error is 0.019605. Same goes to Microsoft Excel. Value of Y is same, and the relative true error is also same. Next, we also compare with the eMathHub website. The value of Y is also same by using 100 steps. The value is 0.663238, and the relative true error is 0.019605. Okay, that's all from me. Thank you.